Deep learning is a sub-branch of artificial intelligence and is a type of machine learning. Deep learning uses mathematical models called artificial neural networks that mimic the way the human brain works. These models can learn complex features and patterns from data and perform a variety of tasks. Deep learning has made great advances in fields such as computer vision, natural language processing, voice recognition, gaming, health, and biology in recent years. In the first part of this lecture, we will cover the basic concepts and history of deep learning. We will try to understand what deep learning is, how it came about, what problems it tries to solve, and what methods it uses. We will also discuss the advantages and disadvantages of deep learning. Definition of deep learning. Deep learning is the process of automatically extracting features and performing tasks from data using artificial neural networks consisting of many layers. In deep learning, each layer takes the input data and produces a higher level output. This output is used as the input for the next layer. In this way, information flows between layers. The last layer generates a prediction or decision for the desired task. The artificial neural network, which is the basic component of deep learning, is a computational model that mimics the connection of biological nerve cells, neurons. An artificial neural network consists of a large number of artificial neurons. Each neuron takes inputs and processes them with an activation function, producing an output. Between neurons, there are parameters called weights. These parameters determine the importance of the inputs and affect the neuron's output. Weights are learned from the data during the training process. Darren Augermanen Tarihi. Darren Ogremme Fikri Aslinda Cook Eski de Gildir. 1943 Yolinda Warren McCulloch v. Walter Pitts Terrafinden Ilk Yape Sinir Agi Modeli Orteya Atilmistir. Bu Modele Nordalar Basit Mantik Kapalari Olarak Model and Mistrier. 1958 Yolinda Iste Frank Rosenblatt Terrafinden Ilk Egitilabilir Yape Sinir Agi Olin Perceptron Gilisteril Master. Perceptron Gerdeleri Alarak de Grusalbier Siniflanderma. Yapabilin Tech Kateman Leber Ogdir. 1960 Lyillerda Eismarvin Minsky The Seymour Paper Terrafinden Perceptronon Sinerliliklari Ortalia Konmustur. Perceptronon Exorgibi Dograsol Olme Problem Liri Cosmei Segi Gosteril Mister. Budurum Yape Sinir Aglarina Olin Iljigi Azaltmistir. 1980 Lyillerda Ice Jerry Yayilim. Backpropagation. Algorithmacy Sezinde Yape Siniraglarinin Agidimi Kalilis Mister. Jerry Yayilim Algorithmasi. Agin Shikardigi Hatanen Agirlik Larara. Gor Turvini Alarikler. Girlik Larry Gunslian Bayer Larak. Agirlik Larry Gunslyan Beer Optimizes Yon Yon My Guide. Uyontem. Kok Katmanli Yape Sinir Aglarinin Egitimine Olanak Saklamistir. 1990 Lyillerda Isiape Sinir Aglari. Destek Vector Machinellery, Support Vector Machines, Gibi Diger Makin Ogrimesi Yontem Lerile Rekabet et Mister. Bu Donamed, Yape Sinir Aglarinin Egitimai Isen Yeni Technikler Gilisteri Mystery. Ornigan, Momentum, Dropout, Batch Normalization Gibi Yontimler, Agen Daha Hisli Ve Daha i.e. Ogrimasini Saglamastir. 2000 Lee Yillerin Basinda Isderin Ogreme Kavrami Ortaya Chikmistir. Jeffrey Hinton VR Kataslari Terrafinden Gelestirilan Derin Inank Aglari. Deep Belief Networks. Oddly Model Kateman Lear Yapida Olup. Her Katman Lembur Yapida Olup. Her Katman Sinirli Boltzmann Makins. 80 Verilin Basit Modelerden Olistic Barderin Olistic Barderin Nobleader. Derin Inats Aglari. Verilerden Ozianeli. Unsupervised. Bur Sekilda Ozelik Shikarabilin Ve Sonrasinda Denetim Lee. Supervised. Bur Sekilda Egidilibilin Bur Modeldir. 2000 Lee Yillerin Sanunda. Isterin Ogrenme. Buk Veri Satleri Vyuksek. Performance Lee Bilgisayar Lar Seyizinde Buki Erivene Kazanmistir. 2012 Yolinda Imaginet Adli Boyuk Bur Goruntu Tanima Yarismasinda Alexnet Adli Darin Ogrenme Modeli. Diger Yonamir Gore, Cook Daha Iei Bur Cook Daha Iei Breyer Performance Gostermister. Buole, Jirin Ogre Minin Popular Ligini Arter Termisteri. 2010 Lou Yillerda, Eisterin Ogreme. Farkly Alan Larda, Farkly Modelerle, Bassaralar Elda et Mystir. Ornigan Eversimli Sinier Glari. Convolutional neural networks, Guruntu tanima, Nestne tespiti, use tanima gibi goravlerde, Tekralayan siniragleri, Recurrent neural networks, Dugaldililema, Sestanema, Metanurtima gibi gorvlerd, Generative carcinoglare, Generative adversarial networks, Goruntu uretimi, Goruntu ilestirme, Goruntu donutur dumusturme, gibi goravlerd, etkili olmustu, Darren Ogermen problem laren, Darren Ogrenme, Yape zekanin onemli bir, alt daladir ve sizitli problemleri kazmeye kalasir. Bu problemler sunlardir, Gorsal algilama. Goruntulerden veya videolardan anlam çıkarmak ve izlemek, Dogel dil islami, insandilerini anlamak ve üretmek. Söz islami, sesleri anlamak ve üretmek. Oyun oynama. Strateji gerektiren oyunlarda insanlara veya diğer yapay zeka sistemlerin karşı oynamak. Takviyeli öğrenme. Çevreli etkileşim halinde odul. Maximize eden davranışlar öğrenmek. Biomedical uygulamalar. Sağlık ve biyoloji alanında verilerden bilgi çıkarmak ve tanı koymak. Sanat ve yaratıcılık. Görüntü, müzik, metin gibi sanatsal içerikler üretmek veya iyileştirmek. History of deep learning. The idea of deep learning is actually not very old. In 1943, Warren McCulloch and Walter Pitts proposed the first artificial neural network model. In this model, neurons were modeled as simple logic gates. In 1958, Frank Rosenblatt developed the first trainable artificial neural network, the perceptron. The perceptron is a single-layer network that can perform a linear classification by taking inputs. In the 1960s, Marvin Minsky and Seymour Papert demonstrated the limitations of the perceptron. It was shown that the perceptron could not solve nonlinear problems such as XOR. This reduced the interest in artificial neural networks. In the 1980s, the backpropagation algorithm facilitated the training of artificial neural networks. The backpropagation algorithm is an optimization method that updates the weights by taking the derivative of the network's error with respect to the weights. This method enabled the training of multi-layer artificial neural networks. In the 1990s, neural networks competed with other machine learning methods, such as support vector machines. During this period, new techniques for training neural networks were developed. For example, methods such as momentum, dropout, batch normalization enabled the network to learn faster and better. In the early 2000s, the concept of deep learning emerged. Deep belief networks, developed by Jeffrey Hinton and colleagues, is a layered deep learning model in which each layer consists of simple models called restricted Boltzmann machines. Deep belief networks are a model that can extract features from data in an unsupervised manner and then be trained in a supervised manner. In the late 2000s, deep learning gained momentum thanks to large data sets and high-performance computers. In 2012, a deep learning model called AlexNet outperformed other methods in a major image recognition competition called ImageNet. This event increased the popularity of deep learning. In the 2010s, deep learning achieved success with different models in different fields. For example, convolutional neural networks have been effective in tasks such as image recognition, object detection, and face recognition. Recurrent neural networks have been effective in tasks such as natural language processing, voice recognition, and text generation. And generative adversarial networks have been effective in tasks such as image generation, image enhancement, and image transformation. Problems of deep learning. Deep learning is an important sub-branch of artificial intelligence and attempts to solve a variety of problems. These problems include visual perception, extracting and processing meaning from images or videos, natural language processing, understanding and producing human languages, audio processing, understanding and generating sounds, game playing, playing against humans or other AI systems in games that require strategy, reinforcement learning, learning reward, maximizing behaviors in interaction with the environment, biomedical applications, extracting information from data and making diagnoses in health and biology, art and creativity, producing or enhancing artistic content such as images, music, text. Methods of deep learning. Deep learning provides solutions to different problems using different types of artificial neural networks. These artificial neural networks are Convolutional neural networks are designed to process grid-shaped data such as images. Convolutional neural networks consist of convolutional layers, pooling layers, and fully connected layers. Convolution layers capture local features by applying a small filter to the input data. Pooling layers are used to minimize the input data and to be robust to scale changes. Fully connected layers perform tasks such as classification or regression in the final stage. Recurrent neural networks. Recurrent neural networks are designed to process sequential data such as time series. Recurrent neural networks take each element of the input data and both produce an output and update an internal state. This internal state stores the past knowledge of the network and passes it on to the next element. In this way, the network can learn sequential dependencies. The most common types of recurrent neural networks are long short-term memory and gated recurrent unit models. Generative adversarial networks. Generative adversarial networks are designed to generate new examples from data. Generative adversarial networks consist of two artificial neural networks called a generator and a discriminator. The generator takes a random input and tries to produce a realistic output. The discriminator takes both real and fake data and tries to distinguish between them. There is a competition between these two networks and both improve. In this section, we have summarized the basic concepts and history of deep learning. We have tried to understand what deep learning is, how it came about, what problems it tries to solve, and what methods it uses. We have also discussed the advantages and disadvantages of deep learning. Advantages of deep learning. The biggest advantage of deep learning is the ability to automatically extract features from data. Deep learning models require less engineering and are more general purpose than traditional machine learning models. Deep learning models can deal with complex and high-dimensional data and achieve results close to or better than human performance. Disadvantages of deep learning. The biggest disadvantage of deep learning is the computational cost. Deep learning models involve a large number of parameters and require a large amount of data. Therefore, hardware such as high-performance computers and graphics processing units are required for training deep learning models. Deep learning models also suffer from explainability problems. It is difficult to understand and interpret the logic behind the decisions of deep learning models. Deep learning models are also sensitive to data quality and security. Deep learning models can be affected by noisy, incomplete, or biased data and can be vulnerable to attacks. The mathematical foundations of deep learning come from fields such as linear algebra, probability theory, optimization, and differential calculus. A basic knowledge in these areas is important for understanding and applying deep learning models. Linear algebra. Linear algebra is a branch of mathematics that deals with structures such as vectors, matrices, and tensors. Vectors are sequences of one or more numbers. Matrices are tables of numbers. Tensors are multidimensional arrays. Linear algebra describes the operations and properties between these structures. Linear algebra is important in deep learning because data and parameters are often expressed as vectors, matrices, or tensors. Linear algebra operations enable the computation and training of deep learning models. Here are some basic concepts in linear algebra. Dimension. The number of elements of a vector or matrix, or the number of axes of a tensor. Scalar. It is a single number. Norm. A function that measures the magnitude of a vector or matrix. Inner product. The sum of the products of the elements of two vectors. Outer product. An operation used to obtain a matrix from two vectors. Matrix multiplication. An operation used to obtain a new matrix by inner product between the elements of two matrices. Transpose. An operation used to change the rows and columns of a matrix. Inverse. It is another matrix that gives a unit matrix to the product of a matrix. Determinant. A number that determines whether the inverse of a matrix exists. Eigenvalue and eigenvector. Pairs of scalars and vectors that give a matrix its product. Speed. A method that decomposes a matrix into the product of three matrices. Probability theory. Probability theory is a branch of mathematics that deals with the modeling and analysis of uncertain events. Probability theory defines concepts such as random variables, probability distributions, expectation value, variance. Probability theory is important in deep learning because data and parameters often involve uncertainty. Probability theory is used to assess the reliability and accuracy of predictions of deep learning models. Here are some basic concepts in probability theory. Random variable. It is a variable that expresses uncertainty. For example, the outcome of a dice roll or the weather. Probability distribution, a function describing the values a random variable can take and their probabilities. For example, an equal probability distribution for the outcome of a dice roll or a normal distribution for the weather. Expectation value, the weighted average of the values a random variable can take on, weighted by their probabilities. For example, the expectation value for the outcome of a dice roll is 3.5. Variance, the probability, weighted average of the square of the deviations from the expectation value of the possible values of a random variable. For example, the variance for the outcome of the dice roll is 2.92. Conditional probability, the probability of an event occurring conditional on another event. For example, the probability of opening an umbrella when it rains. Independence, this is when two events do not affect each other. For example, the outcome of a roll of the dice and the weather are independent events. Bayes' theorem, a formula that calculates the conditional probability of an event by the conditional probability of the other event and the marginal probabilities of the two events. For example, it can be used to calculate the probability of having a disease by the test result and the prevalence of the disease. Optimization. Optimization is a branch of mathematics used to find the minimum or maximum value of a function. Optimization can be done under constraints or unconstrained. Optimization is important in deep learning because the parameters of deep learning models are tuned to give the smallest value of a loss function. The loss function is a function that measures how much the model's predictions differ from the true values. Here are some basic concepts in optimization. Minimum and maximum. Points that give the minimum or maximum value of a function. Derivative, a function that gives the rate of change of a function. Gradient, the vectorized form of the derivatives of a function. The gradient shows the direction of greatest increase of the function. Hessian, the matrix of the second derivatives of a function. The Hessian shows the curvature of the function. Convexity, the condition where the line segment joining any 2 points of a function lies under the function. Convex functions have a single minimum point. Gradient descent, an optimization method used to find the minimum point of a function. Gradient descent starts from a random starting point and tries to approach the minimum point by taking small steps in the opposite direction of the gradient. Differential calculus. Differential calculus is a branch of mathematics used to find the derivative and integral of a function. The derivative gives the rate of change of a function, while the integral gives the area of a function. Differential calculus is important in deep learning because the parameters of deep learning models are updated using derivatives. Derivatives show how the model can be improved with respect to the loss function. Here are some basic concepts in differential calculus. Chain rule, a rule for finding the derivative of a function as the product of the derivatives of nested functions. For example, the derivative of the function f g ess gx ex gxx. Differentiability, the condition that a function has a derivative at every point. Differentiable functions are smooth and continuous. Integral, it is a function that gives the area under a function. The integral can also be defined as the antiderivative of a function. For example, if the antiderivative of the function f(x) is fx, the integral is fb. Fundamental theorem, it is a theorem that gives the relationship between the derivative and the integral of a function. According to the fundamental theorem, the antiderivative of a function is the integral of that function. The applied aspects of deep learning are concerned with how deep learning models are designed, trained, tested, and used. The applied aspects of deep learning include concepts such as deep learning libraries, datasets, training strategies, and performance metrics. Deep learning libraries. Deep learning libraries are software tools for easily building and training deep learning models. Deep learning libraries are available for different programming languages and platforms. Deep learning libraries usually offer a high-level interface and perform low-level calculations automatically. Here are some of the features of deep learning libraries. Automatic derivative, a feature that automatically calculates the derivatives of the parameters of deep learning models. Automatic derivation facilitates model training and reduces the margin of error. Graphical interface, it is an interface that graphically shows the layers and connections of deep learning models. The graphical interface makes it easy to understand and modify the structure of the model. Tensor operations, a feature that supports operations on multidimensional arrays such as vectors, matrices, or tensors. Tensor operations allow efficient handling of data and parameters. GPU support, a feature that speeds up the computations of deep learning models using graphics processing units. GPU support is essential for large data sets and complex models. Here are some popular examples of deep learning libraries. TensorFlow, a deep learning library developed by Google that supports languages such as Python, Java. Java TensorFlow allows to create and run static or dynamic computational graphs. TensorFlow also includes sub-projects such as TensorFlow Lite, TensorFlow, Jazz, TensorFlow Hub, PyTorch. It is a deep learning library developed by Facebook and designed for the Python language. PyTorch enables creating and running dynamic computational graphs. PyTorch also includes sub-projects such as TorchVision, TorchText, TorchAudio. Keras, it is a deep learning library developed by Francois Chalet and designed for the Python language. Keras offers a high-level interface built on top of lower-level libraries like TensorFlow or Theano. Keras is used to easily identify and train models. Data sets. Data sets are collections of data used for training and testing deep learning models. Data sets usually consist of input data and output data. And output tags. Data sets are used as a standard for evaluating and comparing the performance of deep learning models. Some characteristics of data sets are as follows. Size. The number of data contained in the data set. Size is important for training deep learning models. Very large data sets can give better results but require more computation. Data sets that are too small can lead to problems such as underlearning or overfitting. Quality. The accuracy, cleanliness, and diversity of the data contained in the data set. Quality is important for the accuracy of deep learning models. Poor quality datasets may contain inaccurate or incomplete information, or may not fit the distribution they're supposed to represent. In this case, deep learning models may give inaccurate or misleading results. Partitioning, splitting the dataset into training, validation, and testing subsets. Partitioning enables the training and evaluation of deep learning models. The training set is used to learn the parameters of the model. The validation set is used to tune the model's hyperparameters. The test set is used to measure the final performance of the model. Some popular examples of datasets are MIMIST, an image recognition dataset consisting of handwritten digits. MIMIST contains 60,000 training and 10,000 test images. Each image is 28 pixels in size and shows a digit between 0 and 9. CIFAR 10. An image recognition dataset consisting of objects such as animals and vehicles. CIFAR 10 contains 50,000 training and 10,000 test images. Each image is 32 pixels and belongs to 10 different classes. ImageNet. It is an image recognition dataset consisting of various objects. ImageNet contains about 14 million training and 50,000 test images. Each image is of different sizes and belongs to 1,000 different classes. Education strategies. Training strategies are techniques used to improve the training process of deep learning models. Training strategies enable deep learning models to learn faster, better, and more consistently. Some examples of training strategies are pre-processing. This is the process of preparing the data for training. Pre-processing can be done to reduce the size of the data, remove noise, normalize, or enrich it. Small group. The method of training the model by dividing the data into small groups. The small group method allows the model to update faster and generalize better. Early stopping. Stopping the training of the model at the point where its performance on the validation set stops improving. Early stopping prevents the model from overfitting and saves resources. Dropout. It is the method of randomly deactivating some neurons during the training of the model. Dropout prevents the model from overfitting and provides more robust learning. Batch normalization. It is the method of normalizing the mean and variance of activations in each layer during the training of the model. Batch normalization allows the model to learn faster and more robustly. Learning rate. It is a hyperparameter that determines how fast the model's parameters are updated. The learning rate affects the training process of the model. Too high a learning rate can cause the model to miss the minimum point or fluctuate. Too low a learning rate can cause the model to learn too slowly or get stuck at the local minimum. Performance metrics. Performance metrics are metrics used during training and testing of deep learning models. Performance metrics are used to evaluate how well the model learns and how well it predicts. Here are some examples of performance metrics. Loss function, a function that measures how much the model's predictions differ from the true values. The loss function is used to update the model's parameters during training. The loss function is minimized to improve the performance of the model. The type of loss function depends on the problem the model is trying to solve. For example, mean squared error is used for regression problems. Cross entropy is used for classification problems. Accuracy, a metric that measures how well the model's predictions agree with the true values. Accuracy is often used for classification problems. Accuracy is calculated as the number of correctly predicted data divided by the total number of data. Precision, a metric that measures how many of the positive data predicted by the model are actually positive. Precision is often used for binary classification problems. Precision is calculated as the number of correct positive predictions divided by the total number of positive predictions. Sensitivity, a metric that measures how many of the truly positive data the model correctly predicts. Sensitivity is often used for binary classification problems. Sensitivity is calculated as the number of correct positive predictions divided by the total number of true positives. In recent years, deep learning has made great advances in areas such as computer vision, natural language processing, audio processing, gaming, health, and biology. We will see how deep learning models are used in these areas and what results have been achieved. Computer vision. Computer vision is a field of artificial intelligence that deals with extracting and processing meaning from images or videos. Computer vision includes tasks such as image recognition, object detection, face recognition, image generation, image transformation. The use of deep learning models in computer vision has revolutionized this field. Deep learning models are models that can automatically extract features from images and perform complex tasks. Deep learning models have achieved results close to or better than human performance in computer vision. Some popular examples of deep learning models in computer vision are AlexNet. In 2012, AlexNet is a convolutional neural network model that won first place in the ImageNet competition and increased the popularity of deep learning. AlexNet consists of 8 layers and contains 60 million parameters. AlexNet performed much better than other methods. YOLO. YOLO stands for You Only Look Once and is a convolutional neural network model used for object detection. YOLO divides an image into multiple regions and estimates the object probability and class for each region. YOLO can detect objects much faster and more accurately than other methods. FACNA. It is a convolutional neural network model used for face recognition. FACNA measures the similarity between faces by converting a face image into a 128-dimensional vector. FACNA can perform face recognition much better than other methods. Stylogen, a generative adversarial network model for image generation. Stylogen can produce realistic and diverse face images. Stylogen can produce images much better than other methods. CycleGAN. It is a generative adversarial network model for image transformation. CycleGAN can transform between images from different areas. For example, it can transform horses into zebras or summer into winter. CycleGAN can perform image transformation much better than other methods. Natural language processing. Natural language processing is a field of artificial intelligence that deals with understanding and generating human languages. Natural language processing includes tasks such as text classification, text generation, machine translation, text generation, sentiment answering, sentiment analysis. The use of deep learning models in natural language processing has made great progress in this field. Deep learning models are models that can automatically extract features from text and perform complex tasks. Deep learning models have achieved results close to or better than human performance in natural language processing. Some popular examples of deep learning models in natural language processing are BERT, stands for bidirectional encoder representations from transformers and is a recurrent neural network model used for tasks such as text classification, question answering, and machine translation. BERT is a model that can bidirectionally extract semantic representations from texts. BERT performed much better than other methods. GP3 stands for Generative Pre-trained Transformer 3 and is a recurrent neural network model used for tasks such as text generation, text summarization, and text transformation. GPE3 is a model bootstrapped from a very large dataset and contains a large number of parameters. GPT-3 can perform text generation much better than other methods. Transformer, a recurrent neural network model used for machine translation. Transformer is a model that can establish semantic connections between source and target languages using a method called the attention mechanism. Transformer can perform machine translation much faster and more accurately than other methods. ExcelNet. It is a recurrent neural network model used for tasks such as text classification, question answering, and text generation. ExcelNet is an improved version of BERT and can extract richer and more consistent representations from text. SolNet performed better than the other methods. 5. Stands for Text-to-Text Transfer Transformer and is a recurrent neural network model that attempts to do all the tasks of natural language processing with a single model. 5 is a model that takes text as both input and output and can perform different tasks with different pre-processing. 5 is a very general purpose and powerful model compared to other methods. Audio processing. Audio processing is a field of artificial intelligence that deals with extracting and processing meaning from sounds. Audio processing includes tasks such as voice recognition, voice synthesis, voice transformation, voice classification. The use of deep learning models in audio processing has made great progress in this field. Deep learning models are models that can automatically extract features from sounds and perform complex tasks. Deep learning models have achieved results close to or better than human performance in audio processing. Some popular examples of deep learning models in audio processing are WaveNet, a model that directly models the raw form of waves and can produce realistic and natural sounds. WaveNet can synthesize sound much better than other methods. Deep Speech, a recurrent neural network model used for voice recognition. Deep Speech is a model that can take audio signals and convert them into text. Deep Speech can perform voice recognition much faster and more accurately than other methods. WaveGlow, a generative adversarial network model used for voice transformation. WaveGlow is a model that can take the characteristics of one voice and produce a different voice. For example, it can transform one person's voice into another person's voice into another person's voice or a different language. WaveGlow can do voice transformation much better than other methods. Vigish. It is a convolutional neural network model for voice classification. Vigish is a model that can extract semantic representations from sounds and classify them into different classes. For example, it can determine whether a sound is music, speech, or background noise. Vigish can classify sounds much better than other methods. Gameplay. Game playing is a field of artificial intelligence that deals with playing against humans or other AI systems in games that require strategy. Game playing includes games such as chess, Go, poker, arcade, etc. The use of deep learning models in game playing has been a great success in this field. Deep learning models can learn the rules and strategies of games and make complex decisions. Deep learning models have surpassed human performance in gaming. Here are some popular examples of deep learning models in gaming. AlphaGo, a deep learning model for the game of Go. AlphaGo is a model that improves itself by playing against both human and other artificial intelligence systems. In 2016, AlphaGo made history by defeating world champion Lee Sedol-4. AlphaZero, a deep learning model for games such as chess, Go, and shogi. AlphaZero is a model that learns to play by itself, knowing only the rules of the game and beats other AI systems. AlphaZero made history in 2017 by beating AlphaGo 100. Pluribus, a deep learning model for the game of poker. Pluribus is a model that can play and win against humans in both single and multiplayer modes. Pluribus made history in 2019 by beating world champion poker player. DMNA deep learning model for arcade games. DCANE is a model that learns to play by itself by simply taking a screenshot of the game and the score, surpassing human performance. In 2013, DCANE was successful in 49 different arcade games. Health and biology. Health and biology is a field of artificial intelligence that deals with health and life sciences. Health and biology includes tasks such as medical image analysis, medical text analysis, disease diagnosis, drug discovery, genetic analysis, drug discovery, genetic analysis. The use of deep learning models in health and biology offers great potential in this field. Deep learning models are models that can extract meaningful information from health and biology data and make life-saving decisions. Here are some popular examples of deep learning models in health and biology. DeepMind, a deep learning model for Alzheimer's disease. DeepMind is a model that can predict the three-dimensional structure of proteins and help understand the causes of the disease. DeepMind won first place in a protein structure prediction competition in 2018. ChexNet, a deep learning model for analyzing lung X-rays. ChexNet is a model that can diagnose pneumonia from chest X-rays and outperform radiologists. ChexNet was developed by Stanford University in 2017. DeepVariant, a deep learning model for genome sequencing. DeepVariant is a model that can detect genetic variations from DNA sequences and makes fewer errors than humans. DeepVariant was developed by Google in 2018. AtomNet, a deep learning model used for drug discovery. AtomNet is a model that can rank drug candidates and design new drugs using the three-dimensional structure of molecules. AtomNet was developed by Atomwise in 2016.